Welcome to Stemples Nerding It Down. I'm your host Saud Hashmi, and this is the breakdown of Silicon Valley Season 1, Episode 2, named Cap Table. And this is the episode that sets up a lot of tech references, a lot of code screens, whiteboards, and I can't wait to break them down. I sat for maybe 2 to 3 hours just trying to do a lot of research about all the scenes, all the references. To show your support, subscribe to our channel, click that notification bell. Support us by doing that. And without any further delay, let's get into it. So the first scene I want to break down is when Erlich basically has this party set up for the guys at the hostel, and he hires a prostitute, a hooker, named Mochaccina, I think. Yeah, Mochaccina. That's a nice name. He instructs Dinesh to, change the lighting into something erotic. And that's when Dinesh says,
License to kill 9, IB action.erotica.
What's going on?
okay, a few things to break down here. First of all, license to kill, the entire command that he says, it's made up of a lot of things. So license to kill, first up, license to kill is a James Bond reference. All of us know that. James Bond has a license to kill anyone he wants, in any mission, any assassination he wants to do. Yeah, he can do it. And after that, he not only says license to kill, but he says the command license to kill 9 and then goes on to say IB action.erotica. So the thing that gets our heads running is the word IB action. You see, IB action is a macro compiler command that's used in Apple's Xcode IDE, and the IB action, the IB stands for interface builder, which is used to create UI elements in the Swift programming language. So I think Dinesh here has set up this command, this IB action, in his iPhone, and is using it as a voice command to change the lighting of the area. And IBAction.erotica or could be the name of the function that he's created, just to change the colors of the lighting to something more erotic. Moving on.
Business plans that are created in support of new ventures or to implement profound changes in existing venture.
Okay, so in this scene, Richard is, trying to figure out a business plan for his startup Pied Piper. Now, there are two major Easter eggs sort of in the background if you observe. So number one is this photo of a lady with a hat put on. Now, if you happen in the world of computer vision or image processing, you might have heard of the image called Lenna. So Lenna is a standard test image for image processing and image applications, which has been used for a couple of decades now. And it is like standard test image. And this whole photo, which was then cropped out into that square image that you can see, and that was used to test out any image software, just to, it just became a standard of the industry. And it also faced a lot of backlash, a lot of controversy. Some people still use it till this date and some don't. And the second Easter egg that we see is another photograph of an old man. Well, that old man, that's David A. Huffman, who created the Huffman coding. So Huffman was a computer scientist back in the day, and he was a mathematician, and he created something called Huffman coding, which was this prefix code that was created for lossless data compression. It has huge applications, and throughout the series, even at season finale, not gonna spoil it, Richard has the photograph of David A. Huffman, who happens to be a hero of his. Now, one of the best segments of this episode where, all the fans love the segment. This is the Gilfoyle interview segment where, he's sitting on a table, and Jared Dunn from Hooli, who has now come to Pied Piper, he's sitting helping Richard figure out the cap table, which is the capitalization deck. It basically tells you how much equity a person owns in the company. To tell you about Gilfoyle, he is this anarchist kind of guy. I mean, he doesn't resort to authority. He's outlandish, and he's, sitting doing an interview. Not his thing. Anyways, so basically Richard asks him, what do you do? And then he says,
what do I do?
And then?
System architecture, networking, and security. No one in this house can touch me on that.
Okay, that's good to know.
But does anyone appreciate that? While you were busy minoring in gender studies and singing a cappella at Sarah Lawrence, I was gaining root access to NSA servers. I was one click away from starting a second Iranian revolution.
I actually went to Vassar.
I prevent cross-site scripting. I monitor for DDoS attacks, emergency database rollbacks, and faulty transaction handlings. The internet, heard of it? Transfers half a petabyte of data every minute. Do you have any idea how that happens? All those YouPorn ones and zeros streaming directly to your shitty little smartphone day after day. Every dipshit who shits his pants if he can't get the new dubstep Skrillex remix in under 12 seconds. It's not magic, it's talent and sweat. People like me ensuring your packets get delivered unsniffed. So what do? I make sure that one bad config on one key component doesn't bankrupt the entire fucking company. That's what the fuck I do.
Okay, yeah, that's a lot of things to break down because he said a lot. And so, yeah, I'm going to break that down phrase by phrase. First up, he says system architecture, networking, and security. System architecture is it's just a field of computer science that, that is used to understand the behavior, the controls of a functioning system like an app or a server. It could be a physical device, it could be a software device. And networking and security, well, that's just the part of the internet knowledge, a person has, which is very important. It's really essential for a company with large applications to actually have someone who knows about networking and security. Now he says I was gaining root access to NSA servers. NSA, as you know, is this big agency in the United States that does a lot of secret work. Even Edward Snowden, who was called out as a Russian spy and then he had to, go out of the US, even he worked in NSA. Now a question comes up. Is it possible to gain root access to NSA servers? It can only be done if you are a sysadmin, which means you have internal access to the system, you have credentials, you have a CAC, only then can you do it. So maybe Gilfoyle might be, I don't know, he might be lying or he could be telling the truth, who knows? He might have found a way to do that. Now, an important line, a lot of things here are real, okay? Okay, so 4 terms I want to break down here. Cross-site scripting is, it's basically when you inject malicious code onto the client side of a browser, of a user, and then that is used to sort of comes up as a vulnerability and, the hacker can gain access to your side of the things, your client side of the things. DDoS attacks is another thing. A DDoS attack is a distributed denial of service. So a DOS attack, a denial of service attack, what it basically does is that's a single party, a single agent trying to block certain resources to a system. Now imagine a lot of DOS attacks at the same time, multiple resources in deadlock. There's no, resources are stuck up. Imagine a cluster of that, and that's a DDoS attack. So he monitors for DDoS attacks. And how does he do that? He looks for patterns in the network, user behavior, all of that. Emergency database rollbacks. So in any database that is, a robust database has the ability to handle emergency database rollbacks. So what is a rollback? A rollback is basically going from the current state to a previous state of a database. And if you do not put up a robust system in place for the database, well, that will lead to a lot of overwrite of data and you would lose a lot of important data as well. So he handles that as well. And number 4 is, faulty transaction handlings. So a transaction in a database, it's not money transfer. A transaction in a database is basically, it's a change of state from one thing to another. It is registered as an exchange. Okay, that's a transaction. And sometimes the transaction could be faulty. It could be, so for example, one party made the transaction, but it wasn't registered on the database, but the system thinks it is. And so it moves on. It has no procedure for that. That's a faulty transaction handling. So he does all of these things. And yes, this does come under systems architecture. Okay, so transferring half a petabyte data every minute, is this legit? Fact check. It is. Yeah, it could be. I even asked ChatGPT to, tell me about this, and it does give an approximation of, it is possible. It is very possible with the power of cloud computing that we have, multiple devices all around the world connected to the internet. It is very possible. Half a petabyte is 1024 terabytes, and 1 terabyte is 1000 gigabytes. So just imagine how much data flows through the internet every minute. Now, packets getting delivered unsniffed. Okay, unsniffed. Well, what happens is, let's say your data is being sent from one base to another, okay? So, or you're sending someone your data or something. You want that data to go without any interruption or without any sort of sniffing. That's the word, sniffing. We don't want a third party, another person to know what's going on, what the data is. You just want to keep it between the second person, your friend, or whatever. So that's where unsniffed packets come in. The packets, it means what he's trying to say is that the security is so tight, he's so good at it that the packets get delivered unsniffed. So there's no man in the middle attack. And this one final line, he says, one bad config on one key component doesn't bankrupt the entire effing company. What does that mean? So a bad config, well, it could be a software, a hardware, or a process in the system. Well, if this config is bad, well, then it could F up the entire component. From a fundamental molecular atomic level, in fact, if there's a bad part of the function, then it could react badly and, cause a lot of damage. In the very next scene, just after Gilfoyle's interview, now Dinesh, he says,
I'm the only one of these clowns that can code in Java.
which is not right, because later in episode 7, we do see that Gilfoyle is able to help a girl, just debug her code, write some Java code. So Gilfoyle does know Java. Maybe they did not heed some attention to it or whatever. And then he goes on to mention that he can write high, functional, sleek, performant Scala code.
And I write sleek, performant, low overhead Scala code with higher order functions that will run on anything.
Scala is a functional programming language, which most Java developers do know because it's an extension of that. Higher order functions, higher order functions are able to take up a lot of arguments and produce output that's singular, and that's properly mapped out. So that's a higher order function that will run on anything, which means he writes clean code. It's just a way of putting words together and making it seem super techie or something, but it's just that simple. Now in another scene, I did find this bookshelf behind Gilfoyle. And there are 2 important books for techies or computer scientists for that fact. So the first one is the blue book that you can see. It's called Algorithms by Sedgwick, which I am pretty sure if you have been a comp sci student, you must have heard of it at least, or even might have read it in your undergrad degree or what. It's a famous book on algorithms. And the second book, well, the only other technical book I could find was the Mac OS 9 book by Mark R. Bell. And it just looks like it's just a guide. It's an ultimate guide to Mac OS 9. Nothing special. Now, way down.
Dude, they're taking your code apart.
What?
Yeah, did you give those programmer guys access to a player download or something?
Oh, shit. They probably hacked the prototype and decompiled the compression library.
Well, they've got it now, man. They're gonna reverse engineer a version as close as they can without getting sued.
Richard says they might have hacked the prototype and decompiled the compression library. Is this possible? It is very possible. So while I was doing my research for this, I learned about something called decompilers. Just like compilers compile or sort of, transform source code, which is a high level language, to machine code, which is a low level language. Decompilers do the exact opposite thing. They take some machine code, and then they have certain algorithms built which try to predict what source code might have resulted from that machine code. Basically reverse engineering. And how they do it, so they look at the bytecode, which is the compiled version of the software or the module, and they look for patterns in it. So there are multiple decompilers in the real world as well. Okay, so the biggest scene I may ever have to break down, but more are to come in the later seasons. There's this entire scene with the Hooli engineers working on reverse engineering Richard's software, and there's a lot to break down here. A lot. I mean, as I told you, I sat for 2 hours just for this. It was a lot to break down. Let's head into it. Okay, so back in the board, there's a block diagram of something, and a lot of things written as well. Lossy Pied Piper, and what you see are a lot of text, some boxes, some arrows. Then there's a legend for data and control, and there are modules. And you also see a few numbers. Well, numbers in this case, when you're writing a pattern, when you're preparing a diagram for a pattern, you use numbers to sort of give them meaning. So if you talk about, let's say, 110, 120, 140, these numbers ending with the 0 digit, and it's like in the order of tens. So 110, 120, 130, 140. These numbers are used for subcomponents. And if let's say you say 111, 112, then those are the more finer details. This is just how patterns are written. And there are three modules here. So one is the filter bank. In signal processing, a filter bank is an array of band pass filters that separates the input signal into multiple components, each one carrying a single frequency subband of the original signal. And then there's the joint stereo coding that just tells us that an audio signal could have multiple channels embedded, encoded into it. So let's say one could be for a bass guitar, one could be for anything that's left over, some other percussion. And this joint stereo encoding allows for a more efficient allocation of bits. However, in practice, joint stereo is only used with low bitrate signals. And finally, we have what's called a perceptual modular. Well, you can think of it as a feedback loop. It basically improves the systems, basically optimizes the system to handle audio signals and, handle the band pass filters and all. And it all works in perfect orchestration. Moving on to the right side of the board, there's two names written here. Now, the Parks-McClellan reference that you can see. Well, I did some research, and Parks-McClellan are the names of two engineers who came up with the Parks-McClellan filter design algorithm. And what this algorithm does is, so let's say you listen to music or some voices, and you might notice that some parts are louder than the others. The magic tool called the Parks-McClellan filter design algorithm. Yeah, that's a lot of words, I know. Well, it helps make sure these loud and quiet parts are just right. So it is utilized to design and implement efficient and optimal filters. Now, there are two more whiteboards in this scene, and this is just a fact. They just have copied what was written in the whiteboards behind. So nothing new to break down, thank God. There are, however, a few things that I do want to share. So the block diagram that you can see in the left side, in the left board, well, this is just an implementation of MP3 conversion. So what it tells you is that you give it an input sound, and it takes that sound, it passes it through the entire, encoding module. You just give it a sound and input file, let's say MP3, and what it does is it encodes the entire information. It divides the audio signal into different channels, it filters it, then that goes to a stereo coding, it scales it out, it has a loop control, noise control loops, a lot of engineering done. Then it finally goes through an encoder. In this case, in the diagram that we see, it goes through the correction error encoder, which is the part that they're trying to figure out, because that's what Richard has changed in the algorithm. That's what's making Pied Piper so fast, the way it's able to search up and compress data space, finding any song that's infringing on the current song that you have chosen. And on the right side, on the right board, well, it's just a comparison of Richard's FIR low-pass filter and the guys at Nucleus, Hooli's Nucleus are developing. There are a few minor differences in the way that they're using the function approximation of the low-pass filter. And all of these terms that I've explained, well, they're just terminologies in audio engineering and signal processing. You feel free to search up these terms, low-pass filter, FIR filters, only if you're a nerd, right? And then on the far right, you have this chart that Naveen's explaining, and it has these different layers. But those are just the different mathematical transforms and Fourier transforms on the original audio signal. To give you a gist of this entire scene, what the team at Hooli Nucleus is trying to do is that they're trying to, figure out how this software was built. I mean, they could just build another encoding compression software, but the challenging part is the compression itself, because they have not found out what's the golden ingredient, the secret ingredient of this soup that Richard has created in the form of Pied Piper. It's the compression module, it's the compression library. Because once they figure that out, then they can easily beat Pied Piper to market, which we'll see in the coming episodes. So that was the breakdown of episode 2. Hope you liked it. And again, I'll ask you to support us by subscribing. If you like my work at STEMble, do share this playlist, and do share STEMble with your friends, because we intend to make STEM education fun and accessible. And this is what we're trying to do about that. No one's breaking Silicon Valley. We are. So please follow us and let's talk in the comment section. See you in the next one. Hang it there.